Hi everyone, my name is Parham Giamagami. I'm working as team leader of application technology and metallographic laboratory at QATM Mamelson. Today, I will show you how QATM can support you with its solution and options to cut the large components. My colleague Victor Richard, who works as application specialist in QATM, supported me to prepare this presentation. Now I will show you the table of contents and also the structure of this presentation. First, I speak about the basics of cutting large components and the most important features to cut a large component. Then I show you the QATM possibilities and solutions for cutting a large component, at first as an overview and then into details. Then we can start with the examples. The first example is a cutting of a press and hose connection, which is a very long sample and is a mixture of the rubber and the metal parts. The second example is cutting the casing of a gearbox from a packaging machine, which is a very large component with a very large dimensions, and here to cut the samples without often reclamp the sample is a challenge. The third example is cutting of the cast pipe made of chromium nickel alloy. The alloy itself is a challenge and we should use the right parameters with the right consumables and right machine to have a best results. Example number 4 is a cutting of a gear rack, which is the fully automatic clamping and also cutting the sample with the QCut 600 butt. And the fifth example is the cutting a stator and rotor using rotating clamping tool, which are the electromobility components, and it's a very new theme in the cutting of the large components. And at the end, I show you how we come from an idea to a solution in the cutting of the large components. Now, I start from the basic of cutting large components. At first, we should define the different words here. What do we mean by large components and what do we mean by cutting? As you can see, here is the maximum capacity of QCut 350A. At first, I can say that in the QATM, we have three different cutoff machines. We have the precise cutoff machines, which are the QCut 150 and 200A. We have the benchtop machines, which are QCut 250M, 250A, and 350A. And we have the stand cutoff machines, which are QCut 400A, 500A, 600A, and 600 butt. Here, we can see the maximum capacity of the benchtop QCut 350A. The maximum cutting capacity is the diameter of 135 millimeter. The maximum x-axis automatic is 260 millimeters, the y-axis 180, and the z-axis is 140. When the sample are larger and the cut is larger than these dimensions, we should go also to the stand cutoff machines. The second one, what do we mean by cutting? The cutting, we mean the wet abrasive cutting. The wet abrasive cutting, we need the cutoff machine and we need also the cutoff wheel. Here, we used also the cooling to cool the sample and the cutoff wheel during the cutting. And in compared to the milling or to the sawing, we have the minimum deformation that can help us to save the price and consumables and also energy, and the second steps like grinding and plant grinding, and also sometimes we can investigate the sample directly after cutting. Here we can see the basic of the cutting large components. What are the most important requirements for cutting a large components? At first, we need the cutoff machine. The second one is a cooling unit that we use here in QATM, the recirculations cooling units, or we need the band filters. Then in the next slides, we can go to the details. Another one is the clamping tool that we should clamp and fix the sample on the table, that the sample does not move during the cutting. Here we have over 100 clamping tools in QATM that we used for our customers, and now we can also use it for the future projects. The other important requirement for cutting a large component is a consumable, like cutout wheels. As you can see on the right hand side, we see the table that shows which consumable and which cutout wheel is appropriate for which material with different hardnesses. As you can see, for the non-ferrous material, we have the SIC resin bonded cutout wheels, and for the other harder material till to the 700 wickers, we have the aluminum oxide resin bonded. Also in QATM, we offer the diamond and CBN cutout wheels that in the next slides I can go to the details. The other important requirement is cutting mode and parameters. As you can see here, we have a principle that always we should cut from the small contact area and not from the large contact area. And it depends on how we clamp the sample, we can choose the different cutting modes. For example, the horizontal cut, vertical cut, step cutting, zigzag, diagonal, or rotational cut. Now, from the next slide, I can go with each requirement into the detail and we can discuss it together. I can start from the cutup machine. First, I can speak about the name of the machines. As you can see, in our machines, always we have the Q that is represent QATM, and then the cut which present the area that we are working in. It's in the cutting area. It means that QCut is always the cutup machine. Then it comes the maximum diameter of the cutout wheel. It means that the maximum diameter of the cutout wheel in QCut 400A is 400 millimeter, and in 500A 500 millimeter, 600A 600 millimeter. And then we have the letter A or butt, which represent automatic cutting or completely full automatic. Butt is for robotic and for full automatic cutting. As you can see here, we have the four different machines, QCut 400A, 500A, 600A, and 600 watt. That with the different dimensions and different requirements of the sample, we can choose between the machine which of the best one. Cooling system. As you can see in the QATM, we have the recirculation cooling unit that you can see on the upper side that for the stand machines, they are the 120 liters of the recirculation unit. And also, as you can see on the bottom side, we can also use the band filter. In QATM, we can also offer the different anti-corrosion coolants. It means that we use the water with approximately 5% of the anti-corrosion coolant. Then we mix them together and we use it as the coolant for the cutting. The other thing that we should use for the cooling system is the filters. In QATM, we can also offer the different filter cloth and fleece from 800 micrometer to 60 micrometer, and with different dimensions. It means that you cut the samples, you fill the rest material and some from the cutout wheel and from your sample, then the water and with anti-corrosion coolant come to the recirculation unit and we pumped it once again to the cutting machine. With the right clamping tool, we can save the time and we can avoid to reclamp the sample again and again. As you can see on the left hand side, we have also some examples here. Special clamping tool for clutching bell. As you can see, in this clamping tool, we can put the clutching bell on the clamping tool, clamp it on the both sides, and we can also do the parallel cutting. On the left hand side, we see the crankshaft clamping device. As you can see, is a mixture of universal clamping with some supports, and it's also designed exactly for the crankshaft. The other examples we can also see here the CFRP and GFRP panels clamping tool. As you can see, with this clamping tool in QCut 400A, we can clamp the plates and we can cut the samples to put out the plates for the tensile or compressed test. On the right hand side, you can see the special clamping tool for the batteries, where the 9 lithium batteries can also placed in this clamping tool, and with one screw we can clamp the samples and cut the samples on the cap of the battery. The other example is the clamping tool X clamp. In this clamping tool, you can clamp the samples with not regulated forms. As you can see, like stones, here you can see the blade and also the samples that with the normal clamping tool is very hard to clamp the samples. Here with this clamping tool, we can avoid the sample to move during the cutting. In this slide, I want to show you different cutout wheels. In the cutting, we have a principle that the soft bonded wheels are suitable for cutting harder materials and hard bonded wheels for cutting softer material. And in QATM, we have the different abrasive particle and binding material. As an example, abrasive particle can be aluminum oxide, silicon carbide, diamond, or CBN. And the binding materials can be synthetic resin, rubber, bronze, or galvanic binding. Then, with mixing these different abrasive particle and binding material together, we can produce the different cutout wheels. For example, NFA, which is the cutout wheel for non-ferrous material, is a combination of silicon carbide and synthetic resin. The FSB, which is the aluminum oxide cutout wheel, which is good for the metal hard samples, is also the combination of the aluminum oxide and synthetic resin. For the rubber binding material, we can also produce the thinner cutout wheels. It means that when we want to cut and have a very thin cutout wheel, we should go to the rubber binding material. And for the diamond and CBN uh, the cutout disc, we have also the bronze binding material, galvanic, or also synthetic resin. As you can see here, in this cutout wheel, we have the diamond abrasive on the edge of the cutout wheel with the bronze binding. Now I want to show you the different cutting parameters that we can also set to have the best results in the cutting. But at first, we should define the different axes in our machines. Normally, the people think that always the z-axis should be the vertical axis. But as you can see on the left hand side in the standard DIN 66217, the z-axis runs in the direction of the main spindle. It means that when, for example, we have the milling machine, CNC machine, or also cutoff machine, when your spindle is vertical and also rotates vertically, then your z-axis is also vertical. But when your spindle is horizontal and also rotates horizontally, the z-axis is horizontal. It means that in our cutoff machine, that we have the cutout wheel, that the cutout wheel rotates like this, then the z-axis is this axis. Because of that, in our machine, we have the x-axis, which is the forward and backward of the table. We have the z-axis, which is the horizontal axis and we use for the parallel cutting, and the y-axis, which is the vertical axis. Also, in the QCut 600, but we have also two extra axes. One is the B-axis, that is the rotation of the table, and the other one is the C-axis, that is the rotation of the clamping tool. It means that in the QCut 600 but, which is a full automatic machine, we have the 5 axes, X, Y, Z, and also B for the rotation of the table and C for the rotation of the clamping tool. The other part that you can also set the cutting parameter is the display of our machine. In the display of our machine, we have the main menu that we have the parameter menu in it. We have the multi parameters process. We have the consumables and material definition, accessibility that you can give the access to different people like the operator, administrator, or service guy. Then we have the menu for the save and load the programs and the different settings. Now I want to show you the parameter menu. In the parameter menu, you have the different parameters that you can set to have the best results. As you can see in this display, you can also set the rotational speed of the cutout wheel. You can set the motor power, and with this motor power limit, you can also control the feed speed. It means that when you put the 85% for the maximum motor power, and you put here the cutting feed 1 millimeter per second or 5 millimeter per second, and your cut is too high and need more power for the motor, to also protect the motor, the machine set the feeding speed itself. Then we have also the different accesses, and depends on which cut that you choose, you can set the different parameters. For example, here, as you can see, is the actual position, and here is the final position. It means that from this position, the machine should also move 300 millimeters in the x-axis, 100 millimeter in the y-axis, and also here is the parallel cutting. It means that after the first cut, the machine do 5 different cuts for each sample 5 millimeters. And in the setting menu, you can put the thickness of the cutout wheel, and the machine also calculated how to set the cutout wheel in the next step to have the 5 times 5 millimeter samples. Also, we have also different functions and different icons that you can choose on the left hand side and right hand side, like the manual cooling or the laser alignment that you can see here is an option that you can also buy with the machine. When the door is open, you have the laser alignment on your sample, and the laser alignment show where is your cutout wheel, and then you can align your sample very exactly. Then you have also the turtle icon that you can move the axis very slowly, and it's good for the final alignment. Then you have the protection icon that you can protect your table, and you can set the lowest possible position for the cutout wheel. Then you have the manual cutting mode that you can cut the sample manually when the door is closed with the joystick. Different cutting modes like the vertical, horizontal, diagonal. You have the pulse parameters, sample definition, back to the first position, cooling during the cutting. You can also set it off and do the dry cutting, centrifugal filter that you can also do buy as an option. Then you have the 0 point. It means that when you align your sample, you can put the 0 point here as the first point that you can start your cutting. And then we have the final cutting, and also movement of the z-axis. The other possibility is to use the MPP program, multi-parameter process. It means that in this menu, when you choose this menu, you can also save the different positions of the machine. And for each position, you can choose different parameters. And then the machine knows that, for example, in this case, it should do the cut in, for example, 3 different positions. Then the machine do the first cut, and automatically go to the second cut, go to the third cut, and do all the cuts automatically. You can also put more positions, for example, 10 positions, 20 positions, and then the machine knows that the cutout will goes to the right position and do the cut. And with this option, you can also save time and do not reclamp the sample for each cut. From this slide, I want to start with examples. The first example is cutting of a press on hose connection. Here the challenge is the very long sample, 1.5 meter, and the combination of the rubber and the metallic parts. That with the cut you should have the right parameters like clamping and the right machine to do not deform the rubber part or metallic part, or to smear the rubber part on the metallic part. And also on the second sample, the challenge is the also the combination of rubber and metal, and also the when you cut the sample longitudinal, then the different parts of the sample, different size, come together and try to stop the cutoff wheel. And then you can also break your cutoff wheel. Now I want to show you how with the appropriate parameters you can have the best results. In each example, we start with the machine and we go to the parameters and clamping also options. In this example, we use the QCut 400A. In the QCut 400A, as you can see on the left-hand side, you can also find all the information in our websites. They are the precision crossfeed is also possible. Also, you have the safety. It means that when you cut the sample, you cannot open each doors because the doors have sensor, and you can not open the doors. They are all of them locked. The other one is a laser alignment, and also we can here install the rotational tool that you can also rotate your sample during the cutting. Then also with the display and control, you can control all the features of the machine. You can also use the MPP program, as I also said. You can do the pulse. It means that during the cutting, the table moves, for example, 0.5 millimeter to the forward and 0.2 millimeter backward. And with this one, you can also reduce the wear and contact between the cutout wheel and the sample. And the other one is the cutting force dependent feed control. It means that, as I said, we also put the right motor power, the machine can also control the feeding speed. In this slide, we can see how we clamp the sample in the cutting machine. As you can see, because the sample is a very long sample with the 1.5 meter, then we can use the hole on the left hand side of the machine, and we can use the extra part on the right hand side. Also, we should support the sample on the left and the right hand side. As you can see here, we can use some parts to support the sample to have the same level. Also, we can also produce the permanent parts to support the sample and also have the sample has always the same level. On the table, also we can clamp the sample with different universal clamping tools. Here you can see the different clamping tools. Here we have the three universal clamping tools that we clamp the sample on the table, and also we can use the slots of the table to cut the sample vertically. And with the option that the table protect option, you can put the lowest position of the cutout wheel, you can set it, and then there is no worry that the a cutout wheel can meet the table. It means that before clamping the sample on the table, you move the cutout wheel to the lowest position that the cutout wheel cannot meet the table. Then save this as the lowest position of the cutout wheel in the table protect function. And then you can clamp the sample and also put the parameters, and when the sample comes the cutout wheel comes down, or when some operator makes some mistakes to put the not the right height, then there is no worry, the cutout wheel cannot meet the table, and we can use this slot to cut the samples vertically. Here we can see the different parameters and also the results. On the left hand side, here is some table that we use also in the reports that show you which parameters we used. The equipment was QCut 400A. The cutout wheel is the FSI 400, which is the aluminum oxide cutout wheel with the synthetic resin as binding material. As anti-corrosion coolant, we use the QATM standard, as I said, approximately 5%, and mix it with the water. And also the clamping tool is the universal clamping tool. As you saw, we use 3 times universal clamping tool, and for the supporting, we use some supporting under the sample to have the same level. Here we can also produce the permanent metallic supports, or you can use some supports to just put the sample on the same level. Then the cutting method is a vertical cut. It means that in our machines, y-axis, The feeding speed is 0.15 millimeter per second without any pulse, and the rotational speed is very low, is 100 round per minute. It's important to cut with a low rotational speed to avoid burning of the rubber tube. When you use also very high rotational speed, you can burn this rubber or deform it. As you can see on the results after the cutting, you can see that the rubber did not deform, and also you cannot see the smearing of the rubber on the metallic wire, and also the metallic wires are very um, plan, and also you can see that the cut is a plan cut without smearing or without deforming the different parts. And here is the right result for the next step. That can be plan grinding, or also sometimes you can also investigate under the stereo microscope this profile directly after cutting. Here is the second sample that also is a combination of the rubber and metal part, and the challenge here is when you do the longitudinal cut, both sides of the sample can also clamp together and stop the cutout wheel. That's also you can break the cutout wheel. As you can see on the left hand side, the equipment is the same, QCut 400A, the cutout wheel is the same, FSA 400, the anti-corrosion coolant is the same, QATM standard, but the clamping tool is QTool 80. QTool 80, as you can see, we have with the different clamping length. As you can see here is 250, that is the long enough to clamp the sample, and you should use also the other clamping jaws. Our QTool 80 has the standard clamping jaw that deliver with the clamping tool, as you can see on this side, but we have also different clamping tools for different samples. And here to have the best clamping result, you can use this high clamping jaws, that is the clamping jaw 70 millimeter on the both sides, and then you can clamp the sample right. Also here we use some plastic stopper, which is some simple mounting material to stop the both part of the sample to come together and clamp and stop the cutout wheel. The cutting mode is the y-axis step cut. It means that you do the vertical cut, but with the x step cuts. Also, the feeding speed is 1 millimeter per second, is much more higher than the feeding speed of the other sample, and also the pulse parameters we use. It means that we pulse the table 0.2 millimeters forward and backward. The rotational speed of the cutout wheel can be 1800 RPM, much more higher than the other sample, because here the rubber parts are not very high like the other sample. Also, we use the plastic plugs, as I said, to stop the both part of the sample to come together. As you can see, here is the sample after cutting, and here is the result. Here is the plastic stopper that we used, and as you can see, the longitudinal cut can be carried out without any problem. Here you can see also the results. As you can see here, in the higher magnification, you can see that after the cutting, you do not have any smearing of the rubber band on the metallic wire, and do not have any deformation on the metallic wires. When you deform your material, you cannot see the wires like this individually, and also you smear different parts on each other. And then you should also spend time to plan grinding and also grind all the deformation of the cutting away. And with this cut, with the right parameters, without any smearing or deformation, you can save the time by the next step. And sometimes the customer wants to see the profile under the stereo microscope, or with some artificial intelligence programs after the cutting directly. and you can investigate the sample and profile of the sample directly after cutting. Second example is cutting the housing of the gearbox. Here the challenge is the dimensions of the sample. As you can see, we have the sample with 260 millimeter height and 185 millimeter thickness. And then the sample should be cut on the top part. How to clamp the sample, how to use the different cutting parameters or cutting mode to have the best result can be the challenge in the second example. And as the last example, we start from the machine. We show you the clamping options, the different parameters that we use, and after all, the results. We start from the cutting machine, the QCut 500A. Here also we have some features that can help us to have the best results after cutting. At first, the automatic accesses, the automatic X, Y, and Z axis. Also, we have the high dynamic drive up to 80 millimeters per second. Also, the multi-position process can help us to have the different cutting without reclamping the sample. We have also the cutting force control and also some other features like the saving the program after putting the right cutting parameters. Also, we have the sliding door with the very big window that we can see all the details during the cutting, and also the extra door on the right hand side that with opening it you can clamp the big samples in the cutting room. When we are going to the clamping parameters, here we use the swivel plate as you can see on the table, and also two universal clamping tool to clamp the sample on this swivel plate. This swivel plate is a swivel plate with 2 times 60 degrees. It means that 60 degrees on the each side. And when we want to also rotate the sample 90 degree, we should clamp the sample on the one side on the 30 degrees. But also we can produce the different swivel plates with different grades, 60, 70 or 90 degrees. As you can see here, on the each side we have the 60 degrees, and when you want to rotate the sample 90 degrees, you should clamp the sample on the 30 degrees on one side with two universal clamping tools. Now is the time for the first two horizontal cuts. It means that with the parallel cutting, you can also do two cuts without changing the position of the sample. As the last example, you can see on the left-hand side the parameters. The device is QCut 500A, cutout wheel is FST 500, which is the aluminum oxide synthetic resin binding, which is appropriate for the middle hard samples. And also we use the 5% anti-corrosion coolant. The clamping tool is the swiveling plate, 2 times 60 degree, and two universal clamping tools. The cutting method is the horizontal cut for the two first cuts, and then we need one diagonal cut to put the sample out of the part. Also, you can see the feeding speed that we used is 0.6 millimeter for the horizontal cuts and 0.2 millimeters for the diagonal one. We didn't use any pulse for the table, and the rotational speed of the cutout wheel is 1800. Here we can see the sample after first two cuts. Here is a parallel cuts that we used on the both sides to put the one sample out of the part. Then we should rotate the sample 90 degrees. And after that, we can do the diagonal cut to put the sample out of the part. After rotating the sample on the 90 degrees with the laser alignment, you can also align the sample to the right position, and now we can do the diagonal cut. After doing the diagonal cut on this part, the sample comes out of the part. Here you can see the sample. As you can see, the parallel scratches on the sample shows that we have the very plain surface after the cutting. And also on the edge of the sample, you cannot see any break or any deformation. Here, this sample is a very appropriate sample to start the next step that can be the plan grinding. The third example is cutting a cast pipe made of chromium nickel alloy. Here also, the challenge is the dimension of the sample. The pipe is 430 millimeter long and also 190 meter diameter. And as you can see here, the quality of the edge of the sample and the outer diameter is the casting quality. And there can be also some challenges for the cutting. As the other examples, I start from the machine. We are going to the clamping options. We see the parameters and after all, the results. Here, the machine is 600A. Also, why I say 600A, because we don't use the 4th and 5 axis. But as you can see here, the table is the table of 600 baht. But we also can cut the sample in 600A because we don't use the rotational axis of the table. The difference between the 600A and 600 baht is in the baht we have the rotational table, and also you can use the clamping tool for the 5th axis that can also rotate. But here we don't need it. We have the pipe that we can also use some supports on the table, and with some height support and universal clamping, we can clamp the sample, and with the parallel cutting without reclamping the sample, we can also cut many rings on this pipe. Here, as you can see on the left-hand side, they are the parameters. The device is QATM 600A. As I said, the 600A has the rectangular table. You can see the round table here, but um, because we don't use the other axis, the 4th and 5th axis, we can also use the 600A. We use the FSE 600. It means that there is a aluminum oxide with the synthetic resin binding material, which is appropriate for the hard material with the soft binding material, and the diameter is 600. We use the ATM QATM for the anti-corrosion coolant, and then we use the clamping rail on the table for the support, and also two universal clamping tool to clamp the sample completely. And then with the parallel cutting or MPP position, you can do the parallel cutting, or also with the MPP position, you can do the cut on the different positions to cut the rings out. Here we use the horizontal cut. It means that the table moves in this direction, in X direction, and also the cutout wheel is constant, and we cut the sample in this direction. The feeding speed can be also 1.5 millimeter till to 3 millimeters, and the pulsing parameter is 0.1 to the forward and 0.5 millimeter backward, and the rotational speed of the cutout wheel is 1100. With the increasing the feed speed, we can overheat the sample, and sometimes there is some cracks on the sample. And also, when you have the very large feeding speed, you have the wear of the cutout wheel is also more. As you can see, with the 1.5 millimeter, the cutting time is 40 minutes, but the wear of the cutout wheel is 15 millimeter, and you don't have any overheat. But when you use the more feeding speed, like 3 millimeters, then the cutting time can come down to the 23 minutes, but the wear of the cutoff it can be 25 millimeters. And then we can decide which of them are more important for us. The time is more important, the wear of cutout wheel is more important, and the quality of the cutout wheel. As you can see here, here is the results after the cutting. You can cut different rings without reclamping the sample. Also, you can also cut the rings on different part of the sample or with the MPP position. You can also program the rings in the positions that you want. For example, on two ends or everywhere on the sample, you can also cut the rings. Here is the quality of the ring after the fast filling speed. As you can see also, we have the plan cutting, and also we can do the cutting much more shorter, but the wear of the cut of this can be higher. And as you can see here are the results after the cutting. We have the plan surface that we can use it for the plan grinding, and also we can save the time on the second step that can be the plan grinding or rough grinding. The other example is to cutting a tooth rack. As you can see, we have the two tooth rack that should be cut some samples out of the parts. As you can see here, there are the number of the cuts. The first cut is in the middle of sample to put it to the two parts. Then we need a longitudinal cut and the cuts to put the samples out. As you can see, the longitudinal cut can be done at the first step, and then with the MPP position, we can go to the 3, 4, 5, 6, 7, 8 cuts. And here we should not reclamp the sample, because in this case we use the QCut 600 but, and with the MPP program we can do the longitudinal as well as parallel cutting without reclamping the sample. And also the same sequence for the other part of the sample. Also one longitudinal cut and then the parallel cuts to put some racks out. As the other examples, here also we start with the machine and its features that can help us to have the best results. At first, we have the QCut 600 but, which is a fully automatic machine with the rotational round table and rotational clamping tool. Here, the features of the machine, like the automatic cutout wheel measurement. It means that after the cutting, the machine can measure the diameters of the cutout wheel and also can set the parameters once again itself. Here is also, we have the same options in the 500A, and for the 400A is a special design. It means that in the QCut 400A, you can also have the automatic cutout wheel measurement as an special offer. But for the 500A and 600A is an option for the machine that you can buy with the machine. Also, you can also have the remote maintenance. It means that when we have some fault on the machine, the direct fault diagnosis and online support from QATM can be provided via a VPN connection. In this slide, we can show you the clamping options. As you can see here, we clamp the samples with this direction. Also, in every cases, the special clamping device is also available. It means that after we cut the sample and when the customer wants to have the exactly and some special solution for this sample, we can also design one clamping tool especially for this sample. And most of our clamping tools today were the special clamping tools for some customers in before. As you can see here, we clamp the sample on the one side, and on the other side we just put the sample on the clamping devices, on the some support devices to have the same level. Then here we can do the longitudinal cut. Like the other examples, we here also start with the parameters, and also we show you in this table the parameters. The device is QCut 600 but just for 4 axis. We have the rotational table, but we do not have any rotational clamping tool. And then we can use also different cutoff disk, FSC 400 or FST 500. In our machines, the maximum diameter is always in the name of the machine, which is for example here 600, but you can also use the cutoff disk with the lower diameters. Also, the anti-corrosion coolant is the QATM standard with this item number that you can also find on our websites. And also the clamping tool are the universal Weiss Piccolo, that's the universal clamping tools. We have the Q-Tool AT that we also clamp the end of the sample, and also some prism clamping plates to also support the sample. Then we need also the horizontal cutting, which is the longitudinal cut, and also the vertical cutting. The first cut is the cut that we put the sample into two, and then we can use the horizontal cut to do the longitudinal cut. The feeding speed can be 0.7 till 0.2. For the high feeding speeds, we need pulse parameter 0.2 forward and 0.1 millimeter backward. And for the lower feeding speed, we don't need any pulse. And also for the lower diameter of the cutout wheel, we can use the higher rotational speed of the cutout wheel, and for the higher diameters of the cutout wheel, we use the lower rotational speed. The duration of the first cut that put the part into two is 3 minutes. The duration of the longitudinal cut is 26 minutes, and the cross cut for 6 cut is 80 minutes. It means that each chop cut is 3 minutes, and the longitudinal cut is 26 minutes. As you can see also here, we clamp the sample on the end with Q-Tool 800, and also we put 2 prisms to support the sample. And as you can see here is the longitudinal cut, which is the completely direct cut without any deformation on the sample, as you can see here. In this slide, I show you a short video that how we cut the sample. Here is a longitudinal cut. And after this cut, I just stopped the video that the cut can go till this part, and then when we do the complete longitudinal cut, then also we rotate the sample with the 4th axis automatically with the MPP program 90 degrees. Now, as you can see, the longitudinal cut is finished. We rotate the table 90 degrees automatically with the program without opening the door, without reclamping the sample. And then now we do the parallel cutting. It means that one cut, then the cutout wheel comes up, move to the Z axis, in the Z axis to the other position, and do the parallel cutting, as you can see in this video. And after that, we can also put all the samples out of the tooth rack. In this slide, also, there is a very quick introduction as how we can cut a stator or rotor in our machines. In this case, we have the 600A. It means that we don't have the 4th or 5th axis. We have the rectangular table, as you can see here, but we can use the rotational device. It means that we have the one extra axis with the rotational device. Is a QCut 600A plus rotational device. As you can see, here is the table. Here is the rotational device, which is the R axis, and then we have the clamping tool. And with this clamping tool, we can clamp the stators or rotors on the machine to also rotate the sample during the cutting. Here you can see the rotational device, you can see the sample, and also after cutting, you can have the rings of the stator. Here, you can also investigate the sample directly after cutting without grinding or polishing the sample. And here is the very good advantage for the customer that can, after cutting, also investigate the sample under stereo microscope. In this slide, you can see after cutting, we did not deform the different parts. For example, here is the metallic part, here is the isolation paper, we have here the resin and also the copper parts. With the wrong parameters or wrong clamping devices, you can also smear the isolation paper on the resin and the resin on the copper, and then to investigate the copper part in the resin or the pores on the resin with the other illumination settings is not possible, because after cutting we deform the material, we smear the material on each other, and because of that the investigation is not possible. But with this result and with this cutting parameters, we can investigate the sample directly after cutting. Here also the same machine, same clamping tool, but this time a rotor. And also we can use the rotational devices to rotate the sample during the cutting. And as you can see, after cutting, we do not have any deformation on the sample. We do not smear the parts on each other. And after the cutting, we can also investigate the sample directly in a stereo microscope, and we can see the copper parts, the defaults or some defects on the resin, and also we can also investigate with some artificial intelligence program under the stereo microscope. The last example that I want to show you is how in QATM we can come from an idea to a solution. For the cutting the lithium-ion batteries on the cap of the battery, that was an idea and that was a request from a customer that we cut the samples. The first idea was to cut one sample on the cap, and then with the 3D printer we print some clamping tool out of plastic, and then we have the first idea. But the customer wants more samples at the same time, and with the MPP program cut as much as possible. And in QCut 400A, we design in our construction one clamping tool that can also fix 9 batteries on one clamping tool, and then we can cut the samples on the cap of the battery. From this idea, we produce our clamping tool, as you can see on the right hand side. In this clamping tool, you can also fix all 9 batteries with one screw, and you can put the batteries here, you can level it, and also cut all the samples with the MPP program on the cap. It means that at first, for example, these 6 cuts, then automatically the device can rotate 90 degrees, and then on these slots the other cuts can be done. And after all, we can have the weld seams on the cap of the battery out of the battery. And here is one example that how we can come from an idea to the exact solution. In the last slide, I can show you how we react to your requirements. If you have any interest in our cutting machines or clamping tools or cutting solutions or any parameters, then you can register your requirement at the QATM website with filling the request form. We have the contact form that you can find it under the contact form in the QATM websites. Then your contact person, which is our representative in your country, receive the requirements. And then they know that do we have the exact solution for your samples or not. If we have the exact solution, we can present you our solution. And when we don't have it, you can send the sample also with an NDA to us, and also we can prepare the samples for you free of charge, and you can receive the cut parts and reports. And every time, if we have the exact solution or not, we offer you also the live sample cutting in person in QATM Mamelson or as an online meeting. Here, I want to thank you for your attention, and you can also write your questions now. We stay also online after the presentation for a while to answer all of the questions. Please feel free to ask questions. Thank you for your attention, and I hope you a very nice day.